So on the first 20, one of the most important ones is this. I'm not going to even give you the option to ask me about this one. I'm going to tell you, you need to know how to do problems like this. All right. Those three all have some common factors. You figure out the greatest common factor and factor it out to the front. And it'll look like this. This is not the right answer. But it looks kind of like that, where you have the greatest common factor out in front. Factor this. And then compare what you think the answer is to the kid sitting next to you. I'm going to pause for a second while you give that a try. Okay. Have you guys ever seen the exploded view of an iPhone? It's where they show you what it would look like if you took the iPhone apart into all its like little pieces, and they kind of stretch it out over a big like three-dimensional picture, and you can see all the little pieces that come into play to make an iPhone. Okay, well, this is the exploded view of this problem. I'm breaking it up into all of its little pieces. Do you have to do this? No, I'm just trying to show you how you can think about this as exploded view. Now, that's the exploded view. That's all its little tiny pieces. Now I'm going to go back through and see what's in common. Ooh, they all have a 5. Ooh, they all have an X. And then it'd be easy to miss this last thing. What's the last thing? They all have another X. So it's 5xx, also known as 5x squared, that comes out. And then what do I have left? Well, after I've taken these out, I have a 5x. Taken these out, I have a y. Wait, I have a plus in there, sorry. After I've taken these out, then I have a 2x to the third. There we go. When I say took them out, math-wise, there's no, this sounds like I put out a hit on these guys. I just am dividing by 5x squared. That's why those things cancel, because I'm dividing everything by 5x squared. That's why that stuff cancels on the top and the bottom. Okay, so there's your answer, 5x squared, and then 5x plus y plus 2x to the third. Be honest, brutally honest. How many of you got that one right now without my help? Okay, awesome. Now there's another one that's related to that I want to talk about, since it's kind of the same thing, just dressed up differently. 15x to the third y over 25x to the fourth y squared. That exploded view thing would work again. Now you don't have to make exploded view. It's kind of slow, but it's just kind of showing you why it works. And I'm a big one on not just saying, here's a trick, do this. I want to show you why it works. Okay. I do like exploded view, so I'm going to do it that way. For some reason, I find this calming. You guys ever see those videos on the internet where they're like, this is the most calming video ever? They're kind of interesting. Satisfying is another way to describe them. The most satisfying video ever. All right, so all these cancel, and that cancels, and that cancels, and that cancels, and the y cancels the y. All right, to me it looks like I'm done. 3 over 5xy. Raise your hand if you had 3 over 5xy. Awesome. Your basics are getting strong. So imagine for a moment that the first 20 was tomorrow. And it is. And you just were starting it right now. We fast forward ourselves one day. I'd like to know which of the problems is likely to get you or We can always do the, I think other people might have trouble with this one. Yes.
You know when you provide exponents, are you supposed to do the top minus the bottom?
And if you do that, here's the problem.
You get negative.
You're going to get a negative. So what the heck do you do when you have x to the third and an x to the fourth, and you do 3 minus 4 and you get negative 1? X to the negative 1 is kind of complicated because you are not allowed to leave negative exponents in your answers. So I think it's better to just do it the way I did. But isn't this the same as an x to the negative 1? It is.
Oh yeah.
It is, because it's on the bottom. But you see how that could be confusing? Otherwise, if you just go to yourself, I'll just subtract the exponents, but then do you know where to put them? Okay, so I like doing it with the exploded view to explain it. And yeah, when you get more advanced, you absolutely subtract the exponents, but you got to know you can't leave it as x to the negative 1 on the top. You leave it as x to the positive 1 on the bottom.
And if it goes to the negative 1 on the bottom, you just move it to the top.
Yep, you would. We'll do more with negative exponents later this year. So we have a whole day on that. So, all right, yes.
I don't like what it's called, but it's x squared minus 3x minus 2 equals 3. You have to solve it.
Awesome. Yes, thanks for bringing that one up. If I had to bet, I would say that one is the one that most people will get wrong. Okay, so first thing a lot of people don't know is that you have to set this up a certain way or you'll never solve it. What's your first step? Subtract 3 from both sides. Can you tell me why we should subtract 3 from both sides? Yes.
Because we have to
Set it to 0. So many people don't know that. I'm happy you do. Why do we have to set it equal to 0? Well, you do in math a lot. There's a graphic reason why. If you graph this, then you can just see what parts are above 0. That's one reason we do it. Another reason we do it is if we set the y equal to 0, we're finding the x intercepts. See, this is like where y would be. That's another reason we set it to 0.
Wait, intercept or intercepts?
There's usually 2 of them. So y intercepts. So wait a minute. Sorry, I was talking about x. X intercepts. There's usually 2 of them because why? Because it's a parabola, and it's going to touch it twice. Can it be possible to only touch it once? Yes, it can be possible that they only touch once. So it's x intercept or x intercepts, and it depends. We don't know. Yes?
there is none that doesn't touch.
Yeah, what if it doesn't touch it? What if you have a parabola that's like this? Then you'll still get answers if you use the quadratic formula. The quadratic formula can even give you those answers, but those answers won't be real numbers, so they will involve square roots of negatives. All right, so bottom line, first thing we do is set it equal to 0. Why? Because I like the best answer there is saying that we're setting y equal to 0 to find the x-intercepts. So now that it's that way, what's my favorite saying? Somebody remember? Oh, that's sad. I've said it like 35 times. I'll say it again until you know it by heart. If you can factor it, you should. That's my favorite saying. And why? Because whenever you get into a hard question, this helps solve it. Because I'm telling you, at least half the time in this class and all next year, when kids can't take the next step, they're stuck. It's because they aren't factoring. All right. But this one doesn't factor, so it doesn't solve everything. But you should know to try to factor it there. All right, so what if it doesn't factor? Then you use the what? Quadratic formula, very good. So this is the part where you have to have a big old nasty formula memorized. I'll spare you my singing. My whistling's better. Are you guys good whistlers? Nobody? I think it's like a dying art. The hard part? The trill. I'm not very good at the trill myself, but some people are amazing at it. Advanced whistling, you can do this. That sound kind of weird?
I think you're an advanced whistler.
Anyway, okay, so, oh, there's a few birds in here. Some can whistle. One thing I'd love to know how to do, I'm pretty good at whistling, but I can't do that like really loud whistle that like stick two fingers in your mouth and you just like makes a screeching crazy noise. If I was a gym teacher, I would have to learn how to do that, but I haven't learned. Okay, I'm gonna go put my numbers in now. So a lot of people are like, so what are A, B, and C? A is 1, B is -3, C is -5. Now, I had one student in the past hour who swears this was never in the curriculum. Like, I never have seen this before. Now, but remember, people come from different places. He might have come from private school. He might have come from, who knows where he came from. How many of you, is there anybody in here who was pretty confident you never saw this before? Okay, good. I'm glad you've seen it before, because this is like when you're supposed to know. I was surprised, but he was convinced. Never seen it before? Okay, so negative b would be, in this case, negative of -3, plus or minus the square root of b squared. I'd like to just do b squared, and I'd put 9 there. Minus 4 times a, which is a 1, so that's really kind of a nothing thing. 4 times 1 is still 4. Times c, which is -5, all over 2a, which is 2 times 1. Now I'm going to clean it up. X equals 3 plus and minus square root of 9 plus 20. If you're going to mess up, right there is where a lot of kids would have messed up. Because they're going to go, what? You said it's minus. B squared minus 4ac, but it's minus a negative. Because there's a negative in here, and there's another negative, makes it plus. Okay, so then how do I finish it? Well, this one's pretty much done, because you don't know what the square root of 29 is. And 29's a prime, which means I can't factor it. See how it comes down to factoring so often? If this had been a 28, I'd have been able to say, oh, I can factor that. Some stuff goes into 28. 4 goes into 28. All right, so anyway, factoring is a big deal. This kind, I can't simplify it any further. But there is one on the first 20 that's like this. 5 plus and minus 5 root 3 all over 10. Everybody try to simplify that. Let's see if, once again, it's factoring just in a different form. Can or can't you factor? Five comes out. We got left on top. 1. A lot of people think it just disappears. Nope, there's a 1 there. How many of you knew there was a 1 there? Good. And am I going to put a 10 on the bottom? No, I'm going to put a 5 times 2, because if I can factor it, I should. Then the 5s will cancel, and then I'm done. That's it. 1 plus and minus root 3 over 2. That, my friends, is called simplest radical form. A square root is also known as a radical. And it's as simple as it can be, because the square root of 3 doesn't simplify anymore. So that's called simplest radical form. All right, I'm not seeing any cell phones out on desks today, which is awesome. I did earn my grappling hook already. 1/10 of the way in, and I've already got a grappling hook. Sweet. It even folds up so it'll fit into my back, my backpack better, my bat backpack, so that I can play Batman on the weekends. So I'll bring it in when I get it. Subtle reminder: keep your phones away. All right. Next up, you should tell me something. What is the top 20? No, sorry, first 20. First 20 thing that when you hit it tomorrow, you might have trouble with it. Hint. Go look at it right now. I can tell you all the questions. You've got one saved on your iPad. You remember how you got pictures on your iPad and I made you take a picture of one? I made you take a picture of one, so there's one there. It'll be way faster than finding it at algebraninja.com, and you got to click 3 things. Just go into your pictures on your iPad and find it. I had you take a picture of it probably a couple weeks ago, so I don't know how many pictures you take, but you should be able to find it. In a moment, I'm going to ask you to turn your iPad my way so that I can see that you have found your old first 20. All right, please turn your iPads my way. Let me see how many first 20s are up on the screen. Almost everybody has one. Excellent. If you can't find your old one, go find a new one at Algebra Ninja. All right, so act like the test is right now, but you can get one last free help. Is there any of them on there that we haven't talked about and you think I might get this one wrong? Sir. 2 7s over 3 14ths. Awesome. Thank you for thinking of that one. That one comes up in pre-calc this week. And when the kids don't know it, they're stuck. Even though it's an algebra problem, they're going to get it wrong on their pre-calc test because they don't know how to do this from algebra. In the pre-calc world, it's actually weirder stuff, weirder equations than this, but it's a fraction over a fraction. So essentially, you just need to know that you change this to a times problem, and instead of timesing by 3/14, that wouldn't make any sense. You times by 14 thirds. Get what happened there? That flipped, and now I'm going to multiply it.
So you always times by the denominator.
You times by, and then I want you to think of it as a reciprocal. You flip the bottom one.
I did it the other way around.
And it won't work. A lot of people think, well, I just flip either one. No, you got to flip the second one. Okay, now I'm going to factor it, because if you can factor it, you should. 7 times 2. Why is that smart? Because then the 7s cancel. And now it's even easier. It's just 4 thirds, and I don't even have to reduce it because I already did. See what I mean? Some people would rather multiply it out and then reduce it. Fine, but you got to reduce big numbers. I got to do it when they were small numbers. Smarter. Okay, let's do one more like that. You ready? 1/7 divided by 3/21. And when you get all grown up, which is second semester honors pre-calc, most of you guys will see me there at some point. Maybe not have me for a teacher, but I hope you do. Then this would be sine over cosine over sine. And I know you don't know what that means right now, but, and these are angles. And you got to know how to flip and multiply, right? And so my point, you got to be able to handle this when they're easy, because then when it gets weird, it's the same principle that'll apply. So this one, I'm going to take this and I'm going to flip and multiply by it. Multiply by 21 over 3. And then if you can factor it, you should. The 21 factors into 7 times 3. 7s cancel. Boom, boom. Final answer, 3 over 3, which equals 1. Yay. And guess what happens when I take sine over cosine times cosine over sine? I'm going to multiply by the reciprocal. So sine over cosine times, and I flip it, sine over cosine. Ooh, I didn't set that one up nice to all cancel. But what it ends up being is sine squared over cosine squared.
But the angle measurements are different.
It won't matter. All right, so bottom line, I'm trying to show you, even when this gets super advanced, it boils down to a basic principle. Know how to flip and multiply. And if you could do this one, you're good for tomorrow. You don't have to know this stuff yet. But you have to know the base principle of how to divide two fractions. Okay. All right. And that's going to help for tomorrow. But is that like enough for you to all get straight A's? I didn't cover all of them. Do you get, though, that there's a video for every single one of those? So if you wanted to, if you took it really seriously, like let's say Mr. Server decided, because he's rich and insane, to give everybody who aced the test tomorrow a Tesla. Brand new electric car. There'll be some serious studying going on. And then people that ace the tests, like, you just probably practice. I'd do all 5 versions between now and then. I'd just like practice, and I'd check my key and I'd make sure. So I'm just saying, if you really, really wanted to take it seriously, you could ace the test tomorrow. if you wanted to. But I get your life has other things in it right now. You have to worry about English class and science class, and you got sports tonight and whatever. But my point, there's plenty of ways to study for this thing. With 5 practice versions of Algebra Ninja, plus a video for every single one of them. I'm hoping for some serious improvement tomorrow compared to your last test. So we took it the first time, average score, about a 5 out of 20. Took it the second time, average score, probably more like a 10 out of 20. This third time, I'm hoping for an average score about 15 out of 20. Some of you guys can bring that average up. There'll be some people getting the 19s and 20s out of 20. Okay? All right, that's tomorrow. So what's today? Pretty much a review day. So let's say we had this problem. Do you remember that moves it to the which way? Right, 3, and how about that? Up 2. And then what if I threw in a -1 times it in the front? It'd flip it. What's the official name for flip it? Reflect it. And then they're going to ask you over the x or over the y-axis. Well, the way I taught it was not that way, so you have to kind of adjust. But I think the way I taught it is good. I taught it as high-vo. This is the high stuff, horizontal on the inside. And this is the vo stuff, the vertical stuff that's on the outside. So then, I'm okay with you answering on a test that was a vertical reflection. But what if they do it the other way and they say, you have to make one that has a reflection over the y-axis? Which one is that? Well, draw yourself an x-y axis. Everybody draw yourself an x-y axis, label with an x and a y, and then ask yourself, if you're reflecting over the y, that's going this way. If you're reflecting over the y, then are you doing a horizontal or a vertical thing? That looks like a vertical line to you?
It's horizontal.
It's horizontal. Okay, I'm going to just ask you again. What if we're going over the x-axis? Well, first, I better draw you an example of something going over the x-axis. This is going over the x-axis. It's going over the x-axis. Does this look like vertical or horizontal to you?
Vertical.
Vertical. Okay. So verticals go over the x. Horizontal goes over the y. I don't have a snappy way to remember that.
It's backwards.
That's true. It's kind of counterintuitive. It's the x-axis is a reflection of, I don't even want to try to think of it that way. So you memorize it however you want to memorize it. I can tell you this, that if you're going over the x, then I like to just draw myself a picture and go over the x. That's like this. It's flipping over this line. Then that's vertical. Ooh, I know.
What would a horizontal equation look like?
If it was going over the y-axis, it's horizontal. I got a way to remember it. It's horizontal and vertical. Get it? Horizontal and vertical. There. Vertical goes over the x, horizontal goes over the y. So horizontal and vertical. Some kid will be remembering it backwards tomorrow and be like, vertical. So, horizontal and vertical. Okay, you remember it however you want, but you need to know horizontal and vertical and x and y, and you got to keep them straight. Okay, so here's an example of today's typical homework question. I have reflected over the x-axis, and I have moved up 3, and I'm a parabola. What's my equation? Hint, always start with y equals. I'm reflected over the x, I moved up 3, and I'm a parabola. Write what you think the equation is. And be clear about inside stuff and outside stuff, because, you know, it's horizontal on the inside and it's vertical on the outside. All right. Dice of destiny. Who should I call on? We'll let fate decide. You know, this was a big deal back in ancient times. They would actually decide things by casting lots. Have you heard of that before? It's basically rolling dice. Let luck decide it. It says first row, so it's one of you three, and it's you in the back because you got the biggest number, so to speak. Okay, so what did you say it was?
Negative square root of x plus 3.
Close. You had the negative in the, let me make sure that's in the right spot. That's on the outside, and it's a vertical, and that's a vertical. So yeah, you had the negative in the right spot, but a parabola isn't the square root. Try again. Dice of destiny. Pick somebody else. They say row 4, person 2. That's you with the wooden water bottle, which is amazing, by the way.
Is it y equals negative parentheses x squared?
All right. What I feel like you're missing a little part of this. I'm going to read you this one more time. Reflected over the x, moved up 3, and I'm a parabola. Oh, yes.
X plus 3.
All right. And I'm going to put the answer on the outside because that's actually where it's supposed to go. And there we go. What if I had put it on the inside? Then that would have meant that I was moving it to the left 3. But I wanted it up 3, so I wanted it out there. Yes?
What would an equation look like if it was reflected over the y?
Okay, if it's reflected over the y, remember the y goes with horizontal.
Mm-hmm.
Okay, so that horizontal's on the inside. All right, so you asked about one on the inside, so I'll give you one. Y equals negative x plus 4 squared plus 7. There. The negative's on the inside. Why is it on the inside? Because of these parentheses are trapping it in there where it's getting squared. Okay, that would have a reflection over the y-axis, horizontal on the inside, high. This is still the inside. They're both on the inside. This is the vo part. Now, one more thing to point out on this, and I'm glad you brought it up because if you don't have these parentheses, I'll put them in red, you get the whole problem wrong. And it happens all the time. Because a kid goes, okay, I want it to move to the left 4, and I need it to have this inside reflection. I figured out that it's horizontal. That's the one that goes over the y. And I've got this up 7, and they write it like this. Do you get why they would think that that's pretty much the same thing? Look at it. Doesn't that seem like it's 4 to the left? Doesn't it seem like it's got the negative on the inside? So what's wrong with it? It needs parentheses like this. If you don't put those parentheses in there, it won't be right. Why? Because if I distribute out my parentheses, you will get a different answer. You need parentheses on the inside. Yes? Go ahead.
Would negative x minus 4 squared be the same?
Yes, but it's going to mess with your head because now it's got a minus 4, which makes you think it's moving to the right, but it's not. It's really moving to the left. So you don't want to distribute this negative out. You want to write it with parentheses. So let me give you one more example of that. Even after I just said it, I bet a lot of people are going to do it wrong. Try this. This is an absolute value. And I want it to go right 5. And I want it to have a horizontal. Which one would that be over again? Yep. Some of you guys are working that horizontal thing. And then I want it to go up 6. Write an equation for that. It's an absolute value. It goes right 5, horizontal reflection, up 6. This is absolutely an ACT topic. I've seen it on multiple retired ACT tests. They retire them and then they open out to the public to say, see, this is what the test was like. They don't ever tell you the fresh ones. It'd be so nice if they would just release the one you just took and say, here's all the questions you just took and got it wrong, and here's why you got it wrong and stuff. But they don't do that. I think it's because they want to be able to use some of those problems over again for a couple years first, and then they release it. Because it's really actually super expensive to design an ACT test. Because they don't just have like a guy like me make a bunch of questions and just go with it. They test the problems really thoroughly to make sure that they aren't, you know, like smart kid traps. There are some problems that are good questions, but the smartest kids get them wrong because they overthink them, and they can't have that. There's a lot of things that go into making an ACT, so they cost so much that they don't just do it and release it. They want to use some questions over. Yes?
Isn't that what, like, the last section of the ACT?
Actually, it depends.
The last section, I think, that's the one where it's like it could be any different. They have like a couple of different options.
It only happens on certain ACTs. So some people's ACT doesn't have that last section, and some people's does. So it depends on the ACT, and on certain tests, you're right, like in let's say the spring test of this year, they could have thrown in an extra set of like 15 questions, which won't count against you, but you don't know that. You're just taking the test and you're just like, I just got to do this like regular questions. Because if they told you that they wouldn't count against you, people would be like, I don't care, B. You know what I mean? So they don't tell you that they don't count against you, so you don't know which ones, but you're right, they're testing questions. But they don't do that on every test. Okay, let's move on. Absolute value. I hope you had bars like this. And then I need the X in there. And I need a negative in there. And then I need a right 5 in there. And who remembered to put in the parentheses? All right. Unfortunately, that's a third of the class that forgot it. And there it goes. Your grade just tanked. All right. Up 6 plus 6. Yeah, those parentheses are a big deal. You needed them.
Why don't you put the parentheses outside the absolute value?
Because then, think about it. If I put the parentheses around the absolute value, think about what they would actually be doing. That wouldn't change anything. You know what I mean? If I put them that way, it doesn't change the order that it happens. So, you need them here. There's actually a really complicated order thing going on in there, but I don't want to confuse you with it right now. I will eventually explain it thoroughly. And for right now, I just need you to know, when you're making these things, there'll be only a few that have a negative on the inside. If there's ever a negative on the inside, you slap in these parentheses or you're going to get it wrong. Yes?
With this absolute value one, wouldn't it not technically reflect the cost because that negative doesn't do anything?
I get what you're saying, but let's just check something and see. I'll give you an example. I'm going to compare this one to this yellow one here. That has the parenthesis. Okay? I'm going to make a little tiny XY chart for the yellow one. I'm going to make a little tiny XY chart for the green one. And we'll see if you actually get the same points out with the parenthesis in there versus not the parenthesis in there.
No, that's the parentheses.
Oh, that wasn't what you're asking. My bad.
No, just because it's an absolute value, doesn't the negative inside absolute values get canceled out anyway, so it doesn't actually reflect?
I get what you're saying. If we look at a graph, here's a V shape, and if you do a horizontal reflection, that's going to reflect this way, and isn't it just exactly the same? I agree with you. I was just going to try to show you proof that you're right, and then I would stick in numbers. Like if I stuck in a 7, let's see what I get on this green function. 7 minus 5 is 2, and then I make it negative, and then you know what? It doesn't matter if I make it negative, right? So then 2 or negative 2, the absolute value of it comes out to 2. Whereas if I stick in a 7 here, I'm going to get a 2. Does it matter if I have a negative or not? Doesn't matter. Okay, but wait. What if it didn't have parentheses here? Wouldn't this be negative 7 minus 5? And negative 7 minus 5 means negative 12. So when I put in a 7, I got a negative 12, which absolute value of that is positive 12. They are different. So what am I trying to say? I'm trying to say you're right that when you put a negative on the inside, that it doesn't change the graph if it's a simple number. But if it's been shifted, then it does matter. And that's my whole point. This parenthesis thing here, you need those parentheses because it'll be different. So here's really what you're not understanding. If I have a simple one, you're right. Flipping this one doesn't matter. But what if I move it first and then I flip it? Do you get if I move this and then I flip it? It's going to end up being over here. So if it's been moved and flipped, then those parentheses matter. Moral of the story, when you write me an equation like this, and it's got a flip and a move inside, then you need the negative. If this didn't have a move inside, then it wouldn't have mattered. So it's just safest to put the parentheses because you might forget that complicated rule, and I'll just stick to my original. If you have a negative that's been put on the inside, put in parentheses. Because if you happen to put in parentheses here on a simple one, you're not going to get it marked wrong for putting that. You know what I mean? It won't hurt anything. Okay. All right. I know that got complicated, but this is complicated. All right, it's not that complicated. In the end, if you forgot everything else but how to make a XY chart, you could find out where this thing is with an XY chart. Would you please take a moment and find me 3 points, and I'm going to give you the numbers this time. I'm going to ask you to put in -1 and 0 and +1. Please put in those 3 numbers. I got to know that you're good at putting numbers into a function, because if you are, you're going to make it in this test. If you can't put things in an XY chart, you're going to get a lot wrong on this test, and you need to practice it. XY charts are huge.
Wait, this is for the top 20?
Nope.
First one?
Even though this is on the first 20, it is. There's an XY on one of the problems. If you look at your first 20, there'll be a find 3 points on this graph. That's one of the things you need to know. If it isn't on the first 20, it's for sure on the top 20, but I'm pretty sure it's on the first 20. It's definitely on your next test, like the next test from this class, not like the first 20 test, but the next actual real test, normal test. All right, sir, what did you get when you put in -1? I'm going to double check you. That ends up being -5. Absolute value is 5. Then I make it negative again. It's -5. See all the negative and back forward between negative and positive? It's easy to make that mistake. You were correct. -1, +1. Somebody probably screwed up their negatives and ended up not getting 1 at all. All right, let's do another one. Dice of Destiny. Who should I ask? Dice of Destiny are not telling me where they are. That's the destiny. I'm not going to answer your question. All right. It's row 6, 5th person. That's you, sir. Wow, it really wants to talk to you. Give me another one. 0 goes in. You get 2. You are correct, sir. And last person, this is row 5, person 4. 1, 2, 3, 4. That's you.
3.
All right. 1 goes in and you get 3. And you are correct. Raise your hand if you had the same things. Okay, awesome. Any questions? Yes.
How would we calculate like the chances of never being called on by the dice the whole school year?
It's a good question. I would think of it this way. You have to know how many times I'm going to use the dice.
So you use it 10 times a day.
10 times a day? Holy crap.
For class.
Well, there's 170 class days left, approximately. So that means if I did it just once a day, you'd have to do what's your probability of actually being called on? Well, just how many kids are there? It's like 25 kids, so there's about a 1 in 25 chance. That's the easiest way to do it. You do 1 in 25, and then you times it by 1 in 25, times by 1 in 25, times by 1 in 25. it obviously, the probability,
Do 1 in 25.
1 in 25 to the power of how many days of school that we have. And the odds of that, or the probability of that, is extremely small that I would never call any. Okay, anyway, I want to get into the homework for today. So I'm going to pause the video. All right, so here's the ones you have to do and the ones you don't have to do. We are going to do problem 1 in all of its glory. Yes, there's a lot of parts, but they go really quick. Y equals x to the third reflected over the x-axis. Vertical. Oh yeah, out vertical. So it's the outside thing, negative. And then it's x to the third, and then it's down 5. Is that on the inside or the outside if I go down 5? Outside, so minus 5. There it is. Remember, if you're ever on the inside and they do a reflection, you want to have parentheses. X-axis was vertical. Just a dumb little way to remember it, so I knew it was vertical, and if vertical's on the outsides, that's why the negative's out there. Okay, that kind of problem, it shouldn't be too hard for you. On this one, we are going to do number 2 and do number 3, and I have a hint for you on domain and range. Sketch it. Once you see what this thing looks like, oh, it's a square root, except wait, it's been moved to the left 2, and wait, it's been flipped upside down. It's this yellow one. Once you know you're talking about the yellow one, it's not that hard to get its domain and range. Make a sketch to get the domain and range. So you're doing problem 2, A and B, but you are skipping, hold on a second, but you are skipping next, I can't get to my next page. How do I get to the next page? Okay. I want you to just get done with that first page. In your hour, if you can get through problem 2A and B, you're good. That's it. That's all I'm assigning for this hour. Just the first page up through 2A and B. Do both of them. And that's all I have for you for the video for today. Okay. Here, here.